Welcome, ladies and gentlemen. So what I'd like to do is show you how to determine all of the zeros of a function without using any technology. So, you know, in this day and age, I think the best thing to have is a calculator, and you can even type in something on a computer or on your phone and find the zeros. However, kind of going back to a little bit of conservative, teaching, you still might be taking a test without access to a calculator. It could be online or in your textbook. So knowing the idea of understanding what they had to do before calculators, and at least understanding why we use the rational zero test and why this is helpful, isn't very important. So on further problems, I always recommend, especially if you have graphing technology, to always graph your polynomial and determine at least one solution. However, not only to help you find the zero, or at least that you can use, or at least to check your answer. However, I'm going to do these two problems without any technology So to find all the rational zeros, we can look into factoring. And basically, you can see we have four terms. So I would look into factor both of these by grouping. However, when you kind of break it down to grouping, I can't factor them by grouping. So factoring is not going to work. Now, the other thing that we've worked on is when we were given a factor, zero, or root, we could use division, particularly synthetic division, to help us find another factor. And then we could break down that factor again by factoring or solving to get all of the factors, so therefore we could find all of the solutions. Well, in this case, we have nothing. We just have the polynomial. So what we do have, though, is at least an understanding of what the rational zeros are. Because if we have a rational zero, it has to be one of our rational zeros that we're going to find. So the first thing I like to do is determine using the rational zero test. So we do our P over Q, where Q is going to be 1. So I do the P over Q test, or the rational zero test. And again, I list all the factors. So that's going to be 12, 6, 4, 3, 2, 1, all over 1. So my rational zeros, P over Q, is going to equal plus or minus 12, comma, plus or minus 6, comma, plus or minus 4, comma, plus or minus 3, comma, plus or minus 2, comma, plus or minus 1. Whew. All right, now remember, the rational zeros, you could also have irrational real zeros, and you could also have imaginary or complex zeros. So this doesn't tell us all the zeros, but that's a lot of zeros, right, that we have to choose from to determine which ones are work, which ones don't. And also, the other thing is, you notice that the power of my polynomial is 3. That means the maximum number of zeros, real or complex, is only going to be 3. So I have a lot of trial and error to do this. So the best way to kind of do this is to start with the smallest zeros first. So what I'm going to do is I'm going to do synthetic division, because I'm going to test which of these zeros work. So the first one I'm going to use is I'm going to pretend, I'm going to say, well, is 1 a 0 or is negative 1 a 0? And to test that, I can use synthetic division. So basically what I'm going to do is I'm going to call this test number 1, test number 2. And basically, all you're going to do is now I'm going to start testing. Well, you could choose any one of these, right? But I think it's easier to start with 1 and negative 1 as your two tests. So then I now take my coefficients of my polynomial and make sure it's in descending order and you're not missing any. So I have 1, negative 2, negative 11, and 12. 1, negative 2, negative 11, and 12. And this is why we teach synthetic division, going over it quickly, going over so much, because you could possibly do this a lot on a problem, especially if you're not given a calculator. So bring down the first term, 1. 1 times 1 is 1. Negative 1 plus 1 is negative 1. Negative 1 times negative 1 times 1 is negative 1. Negative 11 plus negative 1 is negative 12. Negative 12 times 1 is going to be a negative 12 and 0. Hey, guess what? It's a remainder. Since that's a remainder, that means this is a factor. Let's just go and try negative 1 just to see if we have two zeros, two immediate rational zeros. So I bring down the 1. 1 times negative 1 is negative 1. Negative 2 plus negative 1 is negative 3. Negative 3 times negative 1 is a positive 3. Negative 11 plus 3 is negative 8. Negative 8 plus negative 1 is going to be positive 8, and 20. So that is not a factor. OK? Now, it is not advised for you to go through and do the synthetic division for 1, 2, 3, 4, 5, 6, 12. That's just going to take way too much time. The best thing is, once we see that we have a factor, So now we know that this is a 0. So if x equals 1 is a 0, that means x minus 1 is a factor. OK, so we now know one factor, and now we know the next factor. Now let's go and write in what that factor would be. Constant, linear, quadratic. So I have basically x minus 1 is one factor, which was up there, times x squared minus x minus 12 is going to be my other factor. So this times this equals that, right? Just like if I said 3 was a factor of 12, 3 is a factor of 12 4 times. So 3 times 4 equals 12. OK? So this is a factor. It divides into that. How many times does it divide into that? That many times. So to find all the solutions, I set them equal to 0. Well, here, I can't solve this. But I can look at this, and I do see that I can factor it. So when I rewrite it as a product of its linear factors, I'm left with x minus 4 times x plus 3 equals 0. So rather than testing all of these using synthetic division, I can test it to find 1, and then I can factor to find the further. So my solutions are x equals 1, x equals 4, and x equals negative 3. And write my solution set. OK? I'm done. All right, so now you have the idea, the kind of basic idea. Let's kind of go through another example. So again, the first thing we're going to do is going to be p over q. So I have plus or minus p over q. And you could see, first of all, one thing I want you to notice is, see how all your solutions are actually rational, 4 and negative 3. Negative 3 and 4. Right? So eventually, if you would have done synthetic division for all of these, you would have gotten eventually to your other two rational zeros. But the important thing just to remember is, factoring is going to be the best because not always are all your zeros going to be rational. Again, another video I'll show you, you're going to have irrational zeros as well as complex zeros, which we'll talk about in Descartes' rule of signs late in another video. So once you have an opportunity to factor or solve a by quadratic formula if you can, then do it. All right. So factors of 6 are going to be 6, 3, 2, 1 over 2, comma 1. See if I can fit this in here. So now I'm going to divide the 2's into all these. So that becomes 3, 3 halves. 2 over 2 is 1. 1 over 2 is 1 half. Comma, and then let's do the 1's, which will be 6. 1 over 3 is 3. We already have that. 1 over 2, so that'd be 2. And then 1 over 1, we already have that. So therefore, here is all of our rational zeros. So again, you could go through and test, right, each one of these rational zeros. But remember, it's plus or minus all of these. So the best thing to do, rather than, I wouldn't choose a fraction or a 6, but let's go ahead and choose the easiest one, right? Let's start with the smallest one. Maybe let's write these in order. Let's do 1 half, 1, 3 halves, 2, 3, and 6. So those are all going to be your rational zeros. The best thing I would do is start with 1. That's the easiest. I did synthetic division pretty easily. So let's do negative 1 and positive 1. OK? So when doing synthetic division here, I take 2, negative 3. Let me get a little space. Negative 3, negative 11, and 6. It's in descending order, so that works. 2, negative 3, negative 11, and 6. OK. So I bring down the 2. 2 times negative 1 is negative 2. Negative 5 plus negative 2 is going to be a negative 5. Negative 5 times negative 1 is going to be a positive 5. Negative 11 plus positive 5 is going to be a negative 6. Negative 6 times negative 1 is going to be a positive 6. That equals 12. That is not a factor. OK, so let's try a positive 1. Bring down the 2. 2 times 1 is 2. Negative 3 plus 2 is going to be a negative 1. Negative 1 times 1 is going to be a negative 1. Negative 11 plus negative 1 is negative 12. Negative 12 times 1 is going to be a negative 12. That gives you negative 6. Not a factor. OK, so now, once I know that 1 is not a factor, let's move to the next easiest problem. And that's why sometimes this kind of gets a little hard. I would say that more likely than not, when you're doing this without a calculator, if you have a problem without a calculator, more than likely than not, your zeros are going to be plus or minus 1, plus or minus 2, plus or minus 3, unless your teacher is really, really mean and they want you to do synthetic division a lot. So let's go ahead and try 2. So I do 2, negative 3, negative 11, and 6, and negative 2. 2, negative 3, negative 11, and 6. So I bring down the 2 here. 2 times 2 is 4. Negative 3 plus 4 is 1. 1 times 2 is 2. Wait, 2, negative 3, negative 11, 6. OK. 4, 1, 2. That becomes negative 9. Negative 9 times 2 is negative 18. That becomes negative 12. Again, not a factor. All right, so let's try negative 2. Bring down the 2. 2 times negative 2 is negative 4. Negative 3 plus negative 4 is a negative 7. Negative 7 times 2 is going to be a positive 14. Negative 11 plus 14 is a 3. 3 times negative 2 is a negative 6. That becomes a 0. So yes, now I have a remainder, constant, linear, quadratic. So I have 2x squared minus 7x plus 3. That is one of my factors. Now, to kind of save a little space here, I know that x minus 2 is a 0. So if x minus 2 is a 0, that means, so that is a 0, right? So if that's a 0, that means x plus 2 is a factor. And then we have our other factor is 2x squared. 2x squared minus 7x plus 3 is the other factor. And then that's set equal to 0. So now we go and see, can we factor this? Now you could keep on going. Again, as I mentioned, if you had more space, rip off another sheet of paper and then start doing 3 plus or minus 3 plus or minus 6 plus or minus 1/2. But why go through all that synthetic division when now we can just look into factor or use the quadratic formula? So when I look at this and I say, all right, if I want to factor this, I need to have 2x times x equals 0. So what two numbers multiplied give me positive 3, but add to give me negative 3. So that's going to be a negative 3 and a negative 1. 2x times x is 2x squared. Negative 1 times negative 3 is positive 3. And then my middle terms, negative 1 times x is negative x. 2x times negative 3 is negative 6x. Negative 6x plus negative x is a negative 6x. So that works. Now I have all my factors set equal to 0. So I set them all equal to 0. And then I have x equals negative 2, x equals positive 1/2, and x equals 3. So therefore, my solution set is negative 2, 1/2, and 3. So there you go, ladies and gentlemen. That is how you determine all of the zeros of a polynomial without factoring. Thanks. I'm sorry, without a calculator.